All right, guys, welcome back. This is lecture 3.2 for RAD103, Module 3. And so we are talking about artifacts, and we've already talked about artifacts due to the image receptor. We talked about artifacts due to image acquisition. And so now we're diving into image artifacts due to image processing. This one's a little bit more involved. When we're dealing with image processing artifacts, you have to realize that we're just dealing with software. So this is a software-related issue. When we have the acquisition pixels pick up the amount of X-ray on their plate, and we take that data and we send it to the computer, it's going to be going through an algorithm or a process in order to make that image. One of the things that we have to make sure is that we're giving the computer the correct instructions on which image to create, because different images use different algorithms in order to make the image. So we want to make sure it's using the right software program or the right process to make that image. So on this slide it talks a lot about coning, but this is going to make a little bit more sense as we go. But each image that we do requires a certain amount of coning. For example, when you do an abdomen, you usually don't cone. So the computer is waiting for image to be throughout the entire X-ray plate. When we do a hand, the computer is expecting you to have some coning around the hand. And if you don't have that coning, you're going to be sending the computer too much information or not enough information. And so coning does affect how it's going to process the image, as well as a few other things. So let's talk more about that. One of those things is making sure that you have chosen the correct exam tag, because when you choose to do a hand X-ray, that is telling the computer that it needs to develop this as a hand. And I know that seems to make a lot of sense. But that also means that the computer is going to give us a little bit more of a higher contrast with the pixels. It also means that it's expecting to have collimation in the exam. It means a lot of different things. So if you do a hand X-ray under an abdomen tag by accident, it's expecting the whole plate to be pretty much full, or most of the plate to be full, and it's going to give you a lot lower contrast because it's thinking, oh, this is an abdomen. We need a lot of different shades of gray, as opposed to a hand, which is a high contrast object. And so how it develops that image is going to be dependent on the exam tag that you select. So making sure that you have the correct exam tag is one way to eliminate any type of image processing artifact. And again, like I mentioned, each exam tag has a programmed brightness, contrast, edge enhancement, equalization. All of those things are going to be dependent on whatever exam tag you pick. Now this kind of gets into histograms. A histogram is a graph, and all it does is, if we use this bottom left-hand corner graph, we've got blacks here on the left and whites on the right, and basically it's saying how many pixels had this shade of black, how many pixels had this shade of black, and then you graph it. So like if I look here, how many pixels had this shade of gray, and you can see that the majority of pixels inside that plate had that one particular shade of gray, and you can go down the line, and as we get closer and closer to white, you can see how it kind of tapers off. But there are some pixels that are pretty, light gray, if not almost bordering on white. So that's what a histogram is. Okay, it's just a graphical representation of the different shades of gray on an image, going from black to white and just counting them. And this is, this obviously right here shows you that this shade of gray is the most common shade of gray in this image. That's what a histogram is. You should know, however, that histograms are pretty repetitive when dealing with the same piece of anatomy. So in other words, a cervical spine histogram will look similar to this. An abdomen's histogram will look similar to this. And a knee exam will look like this. And every time you take another cervical exam, every time you take another abdomen, it feeds that data and it updates the histogram as you keep taking those exams. And so a histogram is a good way for the computer to go, oh, I'm taking a cervical spine exam, I'm expecting it to look like this, and if it doesn't, I'm going to do my best to adjust it so that it does fall into these norms, let's say, of the different shades of gray within my histogram. So if we use the example that I talked about before, if you're doing a cervical spine and for some reason you decide to do it under an abdomen tag, your histogram is going to look like this, but it's going to develop it because it thinks it's supposed to be like this. And so any correction that it's going to do is going to be based off of the abdomen histogram, and your processing is not going to be correct. It's not going to look right. I mean, if you can imagine, a cervical spine is going to be a lot higher contrast as opposed to an abdomen. And actually, you can see that. You can see that there's more blacks and then there's a tapering off of the whites. With abdomens, you have a more kind of uniform with a spike of middle shades of gray. So the histogram that you select is based on the tag that you've selected to do that exam. And the computer is going to process that. The software is going to develop it based on the tag that you selected. And if it's off, you're going to have problems with your development or processing. Now, I'm also going to remind you again that coning is important. So if we look at the knee x-ray, with the knee x-ray, you generally do not use the entire plate. You're going to use a little bit of it and you're going to cone down. And so that coning has to be a part of that exam. If you don't cone, if you leave your cones wide open for a 14 by 17, you're going to have a lot more black pixels. And so that's going to throw off your histogram, your acquisition histogram. And so that's going to skew how it's developed. Same thing if you have an abdomen and you decide to cone down to just one particular area of the abdomen, that might throw off how it's developed. So you have to keep in mind that coning is also a big part of developing the image correctly. If there's a small body part or an extremity, you must cone, otherwise you're going to get a bad histogram. You're going to be giving the data, too much data to the computer, and its shades of contrast are going to be thrown off because of that. All right, lookup tables. Sorry, I don't know where to put myself on this slide. I'm going to put myself here. Lookup tables. A lookup table is a reference histogram that the computer uses to develop your image. I mentioned that, of course, each exam has its own basic histogram, and that every time you take a new exam, let's say you do a cervical spine, it updates the current lookup table to include your data too. So it's always updating its lookup table. The lookup table is used by the computer so that when you're doing a cervical spine, it's going to look for a histogram similar to this, and it's going to develop the image based on the histogram, realizing that, okay, there are other things to think of. There should be some collimation, so I need to be aware of that. I need to be aware of the edge of the exposed field. I also need to make sure that it's a high level of contrast because it's not an abdomen. I'm going to develop it with more bones and a little bit less with some soft tissue. And other than that, there should be nothing else involved. So all of those things come together and make the algorithm of how that computer is going to process the data and make an image out of it. So that's what a lookup table is. It's just that reference histogram the computer is going to use to develop your image. The other thing that it might do is that it's going to correct your shades of gray. So if there's any incorrect technique that you used, let's say you underexpose the image or overexpose the image, it's going to use these lookup tables to help create the perfect shade of gray. It knows what the ideal shade of gray should be and is able to adjust all of the pixels because remember, each value is just a numerical value representing a shade of gray. So if all of our values are a little bit light, everything is too white, then it could just say, just add, I don't know, 10 points or 20 points or 1,000 points to each pixel value and make it darker. And it does that. So here's your histogram. You can see the histograms. And we've got an underexposed image, a perfect image, and an overexposed image. And this is represented by the histograms down here. So we can see that most of our pixels are under the white. So remember, these characteristic curves or Herter-Dirichlet curves, the toe portion is generally where the whites are. The straight portion are your shades of gray. And then the shoulder portion are your darks or your blacks. So here, the histogram is mostly on the lighter shades of gray and the whites. And that's what this image is showing. Again, we'll skip this because this one's perfect. But here is overexposed. So I've got too many blacks, too many dark shades of gray in my image. And so you can see that my histogram is mostly represented with the shoulder and the dark shades of gray of my straight line. So what the computer is able to do is say, I'm identifying this as being too dark. I'm identifying this as being too light. And I'm going to adjust those shades of gray and put my histogram right in where the straight line is, because those are my shades of gray. It makes the adjustment. And so you can see here, now we've gone from underexposed to perfect. The histogram is now within that straight line area of my characteristic curve. We've got, this was already perfect to begin with, and this was overexposed. I have a lot of dark shades of gray. I've decided to take my histogram, or I've decided to take my straight line and move it and adjust those shades of gray, and I get that perfect. And so that's just kind of an example and a nice graphical representation or image to show how the computer is able to take the data that you give it and correct it based on a histogram and understanding what the correct shades of gray are for that particular X-ray. And on that bombshell, I'm going to stop this video here. We're going to continue to talk about these types of artifacts in the next video. So hopefully I'll see you there. Bye.